Well, imagine this. You see a beautiful painting and you might think it's magic, but when you look closely, it's just brushstrokes and colors coming together in perfect harmony. AI works in a similar way. What we call intelligence in these models isn't magic. It's just numbers working through a complex yet elegant system. By the end of this video, you will see how these numbers, much like those brushstrokes, can come together in a way that would make sense to you. A few weeks ago, I recreated GPT's entire architecture in a spreadsheet. And I know what you're thinking. These intelligent AI models can indeed run in a spreadsheet. That's also how we can visualize these complex processes into something simple and interactive, which in my mind, it's the best way to learn. All right, so let's take a quick look at the entire architecture from an overview. You will see that the entire structure contains embedding, three transformers, and then the result, the output part. And if you look slightly closely, you will notice that the transformers, each one of them are almost identical, and the data will go through it 3 times. The way to read these tables is if you look at this one, this is a snippet of the very core part of the transformer, which is the self-attention section. See that in these tables, you will see purple and green matrices, and these are the matrices that are used to do the calculations. The purple ones means they are parameters, and the green ones means they are actual data being processed, right? So imagine like these green things going through the purple boxes, and then it came out slightly differently. So this is the essence of the entire architecture. It's just these actions are being done repetitively and also in different forms. And the good thing about using a spreadsheet to do it is that you can actually see the shapes of those matrices. So when we say shapes, I actually mean the literal meaning that these matrices has different length, different heights and width. Different heights and width actually represent different things in the model, and they have to go through certain calculations which resulted them in different sizes. And you can also see that because they're running through different pipelines, especially like for this one, which is called multi-layer perception, which uses a very large matrix to do the calculation for a relatively small number of data. But in essence, this is how it's done. The parameters that are used here are actually being segmented into smaller chunks. It's not one big table. It's a lot of tables doing different things. So when we talk about training, what we're actually talking about is fine-tuning these little numbers on each of the parameters so that as a result, it outputs the desired result for us. But when you are starting this thing, especially like in this particular spreadsheet, all the numbers are random, right? So they don't actually provide the correct output. We will be starting with embedding. So a lot of people don't really understand what embedding is, but imagine when you're using ChatGPT, you're inputting words, actual human understandable words, but the computer has to, somehow turn that into a number that can be processed. This particular process is called embedding. So what does embedding mean? When we're using ChatGPT, you type in some words, a question, a sentence, and these words are being processed into numbers so that it can go through the pipeline I just showed you. Each of these numbers are actually representing meanings of these words on different dimensions or different perspectives. Let's simplify this multidimensional embedding thing into a flat 2D surface. So imagine I'm assigning 4 and 3 to the word actor, 4 and 6 to actress, boy with -4 and 1, girl with -4 and 4. And what you notice is that these are vectors pointing at different directions with different length in a way that this particular location on this 2D plane actually means actor. And different position will have different meanings. And then you can store tokens into this library or dictionary. But in reality, there are much more dimensions than two, because we want to have more dimensions to represent the different qualities or details of the meaning of this word. So two is basically not enough for it. So there's this one detail of the whole embedding mechanism that really helped me to understand it. If we take a look at actor and actress, these two vectors, the difference between them is a smaller vector pointing from actor to actress, right? The difference between actress and actor is the gender. So going from actor to actress is basically male to female. And that particular vector can also be used to describe the difference between boy and girl, because the difference is essentially the same thing, going from male to female. And in the number world, this difference will be described as 0, 4. So that's the magical part for me, that all of these meanings somehow they are being compiled into this magical multi-dimensional space that it actually made sense on itself. So with that being explained, we can look at the very first part of the pipeline, which is embedding. What's going on here is that for the word that's being provided to the system, in this case, 6 characters, CABBAC, they're being given to this matrix by adding two things. One is called token embed and a position embed. The token embed is what we were just describing. They were parameters that are used to process the token index so that you can create this input embed, which represents its meaning for each letter. And then the position embed is also there to help you by providing a position information into the sentences. The reason why for that is when I say things like I like you and you like me, they were essentially the same 3 things, right? Me, you, and like. But if you position them in different order, they actually mean different things. So the position embedding is very important to be inserted into this input embed to process the data so that it carries that information to be further processed. If I move down from this particular location, you will notice that the other things that's influencing it is actually on the matching row or column, which created this 11 by 48 matrix. So it's basically the very starting point of the embedded version of the word that we typed into ChatGPT in its numbered form. And each row is basically on a certain dimension. We're using these words to represent CABBAC. But obviously in this case, we have 48 dimensions. So 48 different perspectives to represent these 6 letters, if that makes sense. Okay, moving on to the next part, which is layer norm. This is mostly a math-based step, so it doesn't carry a lot of meaning to it. It's just we start with the input embed we have from here. It's just carried over here without any calculations. You can also see the calculation, which is right down here. These are just calculations that's done to provide some kind of a mathematical quality to the numbers, right? So they're just being pre-processed before going to the next step. And then moving on to the next, which is probably the most important part of a transformer, which is the self-attention section. Self-attention basically means that when we are trying to decide on what is the next token, we have to look back in the previously added words and to use that to predict the next one. And I'll show you this particular drawing that I have. So imagine we're trying to guess who is the murderer. And the self-attention basically means that when we're trying to do the calculation, it's actually taking the data from some of the previous words who actually has a huge influence on the end result. And there's also the ones that are less important. Let's imagine ourselves being the transformer itself. When you see this sentence, you're trying to guess, okay, what would be the next word? in your calculation, what you might see is you will have the word dead, and you'll have his colleague, and then also a word vegetarian. Obviously, if you look at this thing, you'll be thinking, okay, it's probably not vegetarian because it's not really relevant to this story. And then one other thing you picked up was that, oh, this sentence was actually in the very end of this story. So it's kind of a review of who is the murderer. So in this case, you'll be thinking, oh, actually, his colleague might be the most appropriate word to be put in here. So this is how it works, right? So like if you think about how your mind works, you're kind of gathering information from previous sentences, and then you do this internal magic thing in your own brain that help you to pick the right word for it. So this is how it works in a nutshell. So going back to the self-attention section, what's actually going on here is the layer normed data are being processed with three new set of data. It's the Q vector, the K vector, and the V vector. And these three represents query, key, and value. These three things actually different tricks for us. Before we look into what these three things are doing, we will take a look at the output. So the output is basically a matrix that we're using to guess what would be the best result. But like I said earlier about the self-attention mechanism, which is using the previous words to predict the next word. That's why in the attention matrix, what you see here is actually a triangle-shaped matrix, because the triangle on the top right corner, it's being removed because they're not useful, because we're not using future words to predict previous words. As a result, we kind of created this attention matrix, and the softmax process is more of a mathematical process. And as a result, you get this V output, which is the desired value from this particular section. If we took a look at the spreadsheet itself by putting your cursor over here, you will notice that it's actually influenced by the K and Q vector, right? The first attention matrix box. And you'll also see that if I'm going downwards, the Q vector is actually moving to that direction. And if I'm moving to the right on the attention matrix, the K vector is going to move forward. What this means is that the Q vector actually carries information of this particular token that you're trying to process. And then the K vector, the key, is actually carrying all the information combined from all the previous words that you're using. And then the value vector is used in the last matrix, in the value output, by adding all of the previous information together and then insert it into this new value output. So when you're playing with this spreadsheet, what you should be looking for is how are they influencing each other, right? Which column is influencing which row? In this particular case, the output, if I were to explain it to you, is that for each row, it's also the particular dimension, right? This dimension 6. And 2.1 over here represents the very first letter. 1.4 is the second letter on the dimension 6. And the next thing you will also notice is that this whole head 0 is actually being done multiple times. So that's why it's called multiple head self-attention. In this case, it's been done 3 times. And each time, they're using different Q vector, K vector, and V vector. As a result, you will have a value output 0, a value output 1, and a value output 2. And these 3 are going to be joined together in here, which I named it value output 0 plus 1 plus 2. It's actually a combination of these matrices just being piled up together. So then you enter the next stage, which is projection. And in this stage, it's being processed in a slightly simpler fashion. I don't really know what's going on mathematically, but it's just one of the processes that's being used to refine the previous results, almost like polishing them. And moving on to the next section is the multilayer perception section. These are like one of the biggest section of the data being processed in terms of the size of those matrices. All the information that we trained into the model are somehow stored in these kind of small parameters, right? They're massive, right? We're talking about hundreds of billions of parameters like this. So they're being molded in a certain way that it directs the data putting into them. That's why you see these kind of massive blocks. After we explained what the MLP is, zoom out a little bit, because you will start to see that all the stuff I've explained earlier are being constructed into this multi-step process. And this process is being repeated 3 times in NanoGPT. So you can imagine that, to me, again, not from a very technical perspective, but to me, this is like training something or prompting someone with multiple tries if the first one doesn't work. But also to notice that for each step, they're not actually the same parameters. They're different parameters that's being trained. So they actually carry different information. And in the very last part of the process is the output. And it starts with a normalization of the data, which then turn it into what it's called input embed. The way you can see the very last part is that we're kind of going through all the process before. We're trying to turn what we had here with massive information in it. But it's the shape that we don't want. We don't want a shape that's this big. We actually want a shape that can help us to determine what we want for the end result. So this calculation for logits is basically transforming that shape into a 3x11 matrix. And this thing also goes through a softmax process so that it becomes numbers that we can actually use to determine which one has the more weight. What you can try in the actual spreadsheet is that you can change these purple parameters by resubmitting them, so it's going to refresh and everything is going to be regenerated randomly. And then you will also see as a result the yellow part will change accordingly. But of course this is the wrong number because the parameters are not the actual parameters. You will see that it's actually influencing the end result. Right, so after all the explanation, I hope this video helps you to understand how these numbers are being processed within this spreadsheet structure or the pipeline, and so that you don't see them just as numbers, but they started to have meanings for you. And also like what embedding is and why a self-attention is actually helping you to predict the next token. And these are basically the very core of a transformer. But one of the things you will also notice is that although we're seeing a lot of parameters here within this one already, which has about 85,000 parameters, but the modern day large language models contains hundreds and billions of parameters. So they're too big for a spreadsheet, to be honest. But you get the idea. You have multiple layers of these processes being put together in a slightly different ways to form their own transformer or their own models, because the smart people behind them decided to have a slightly different structure for them. And we might not know exactly what's happening within it, but that's the beauty of training these models, because you don't have to understand them to build them. And for me, I used to be a product designer, and I take apart of things for me to understand how they work, how they function internally, so that I can design them myself. So this project started as a self-learning process for me to understand what's really going on within a large language model. And I hope it's doing the same thing for you, so that if you're ever going to be using a large language model, or if you're building some kind of an application on top of them, this will help you to understand why they work the way they work. So that's a wrap, and I'll see you next time.